All right, next bit is, this is the wrong page. Okay, next bit is Amazon Lambda functions. So Amazon Lambda functions is their, is their serverless platform. And an application is anything that does something. So let's say you have a Hello World application, right? So you call the application or you run the application, right? And in return, the application will print Hello World on the screen. So in terms of an API service, right? An API service will accept requests and then send back responses, right? So much like a web page, I go to this address, this awsamazon.com Lambda. I request the page from this address, and then I get this whole web page back. So if you think about a Lambda function is just a platform for you to host your application code. So if you wanted to create a Hello World application, it allows you to run that application and have it always available and listening. So what would happen? Okay, let's scroll down here a bit. Let's talk about web applications. All right, web application. Let's say you start from this bit where the user clicks on a link, right? And they go via API gateway, Amazon API gateway. So I remember we talked in the previous session about API gateways. It's kind of like a web server, which can service or respond and listen to any requests that come through. In the basic form of a website, it would be accepting just the URL. But then in other APIs, you can post and put information, and your API will accept that information and process it. Okay, so let's say you've got a user here, and they are going via the API gateway, and they're trying to hit the Hello World application. So what would happen is the user sends a request to the URL, and then that request gets forwarded onto a Lambda function, and then the Lambda will send back a response with Hello World. Now, a more advanced approach would, let's say we followed the same pattern, but this time let's provide our name. So, Trevor, I provide a variable in my payload labeled name and Trevor, and I send that through. That label gets passed into Lambda function. Maybe Lambda function will process that and then accept that new name parameter and would say, okay, my response is no longer just hello world, it's hello Trevor, how are you today? And then send that back. So in this example, we've gone from a very static response and now we've changed it to a slightly more advanced where we are accepting input variables and we're still processing that input and then sending that back. Then let's say this is a little database system, and in the database we've got a Amazon DynamoDB at the back, and let's say I have 2 accounts on the system. This time I still provide my name, I send it through. This time the Lambda function not only will greet me, but will also have a summary of how many accounts that I have. So it might be like, I start off, send in my name to API Gateway passes on my name to Lambda function will start saying, hey Trevor, and then we'll make another call to DynamoDB, try and retrieve all of the accounts linked under my name, return all those accounts, and goes, okay, I can see that you've got 2 accounts. Let me formulate a message. Hey Trevor, I can see that you've got 2 accounts with us. What would you like to do today? And send that message back through API Gateway and back to me to be presented. So in these examples, I'm just showing you how Lambda is just an application platform for you to host your application code, and your application code can go away and do whatever it really wants to do, be it calling database backends or consuming input variables, for example, name, and then processing that input data and then sending it back out. So in these use cases, the Lambda function is a kind of single function application. It does one sort of thing, and these functions are not meant to be overly complex. So if you think about Google.com, and if you think that the search engine is one massive big application, well, Lambda functions are not meant to be that. They're not meant to be a big, massive application. The way that Lambda functions exist is you end up building multiple Lambda functions and you combine them together, or you group them together, and together they form and serve a purpose. So back into our example, let's say we have a Lambda function. You might have one Lambda function that its sole purpose is to accept, let's say, new account details. And when it receives new account details, it will write that new account into DynamoDB. Then a second Lambda function, its purpose might be to simply search the DynamoDB, get all of that data, and then formulate that data and present the account details back. And then the third might be updating an account. So it might accept an ID from the user, process that data, make a call into DynamoDB with that ID and retrieve the data back, and then make any updates that it needs, and then push those back to DynamoDB. So in this kind of example, we've got 3 Lambda functions. Each of them are small applications with a clearly defined scope and purpose. But together, we've got 3 functions, and now we have built greater functionality in a way that we can now manage the accounts that are stored on DynamoDB. Okay? So yeah, that's all I really wanted to cover. I'll just go a few things. Again, AWS Lambda is coding without servers, so we don't actually have to think about, do I need to boot up a Windows server? Do I need to boot up a Linux server? Do I need to make sure that I have the correct applications already set up? So do I need to have Node.js? Do I have to have Java installed? Do I need Python installed? All those kind of things are kind of managed, making sure, do I have the latest version of Java? Or if there's some security patches that I need to apply to my Windows operating system or my Java platform, all those kind of things, they're looked after by Amazon. And so also when you think about servers, you have to boot them up and leave them running, or if you turn them on and off the whole time, then you have to wait for the machines to turn on and then turn off. And then you end up having to, spin up the servers. You've got ongoing power costs, or if you're going to have physical machines, then you're going to have to buy the hardware, or you're going to have to lease the hardware, and then you have to think about networking. Lambda functions are there to remove all of those issues. You don't have to deal with the operating system, no infrastructure. You don't have to deal with the network. A lot of those things are all managed by Amazon. And so you just have your application code, you build in your own development environment, and once it's ready and working, and say, for example, if you were simply building a Hello World application, if it was responding with Hello World, then you could basically host your application code on AWS Lambda, and it can start accepting and listening for new requests that come through and processing those requests and responding accordingly. Now, Lambda is much like every other service in Amazon where it's billed according to consumption base. So it depends on how many requests it is processing. So it could be a fraction of a cent per request, basically. All right, so let's just go through a few of these examples of how it works. Now we were looking at this one. I don't really Okay, in this example, it's saying that the whole weather application and all of its images and website artifacts is hosted on S3. Now let's say a user views that website and clicks on a link, and that link is kind of linked to API Gateway. In that process, that link or link click creates a request. That request gets sent to Lambda, and Lambda will retrieve the data from DynamoDB and then get all the latest weather data and send it all back. So back via Lambda and then back via API Gateway and then presented to the user. So in this example, the Lambda function is a very, it's got a very small scope. It's well defined and it does one thing basically. Okay, file processing. There could be another example where you've taken a photo, you've uploaded your photo into a S3 bucket, then the moment that file gets created on S3, that automatically triggers AWS Lambda to process, and in that process it sends a address, an S3 address of where to find that new photo that you just uploaded. And then what happens is maybe Lambda function receives that address and retrieves the file from the S3 bucket. Maybe it might say convert your color photo to black and white, and then after it's converted it, it might save down the black and white photo back to S3. In this example, it says photos resized into web, mobile, and tablet sizes. Okay, so it accepted a photo. The photo address was sent to Lambda. Lambda got that address and then downloaded that photo from S3. Then it went to resize that photo into 3 other image sizes, and then it probably will save those 3 images back onto S3 for other purposes. So again, you've got a process which is has a start and stop and does one thing. And so Lambda functions are limited to 15-minute execution windows. So whatever you're doing has to fit in with a 15-minute time frame. What else we got? We've got Kinesis, and I'm assuming every let's say 1 minute, it might trigger a Lambda function. That Lambda function would probably tap into the Kinesis data stream, pull all the new records, and then save that little micro batch into DynamoDB. All right, then web applications, that's the one we just covered. IoT, that is very similar, still Kinesis. So Kinesis in this example is being used to cache the streaming data. So the sensors from the tractor would be continually sent from the tractor into Kinesis, right? So maybe it could be getting updates every 5 seconds. Kinesis will just act as a little cache or staging area where all that data would just pile up basically. And then every, let's say 5 megabytes worth of data, it might go and call Lambda function to tell it, hey, Lambda function, can you come over and download the 5 megabytes worth of data and process that data and then send it onwards. So that might be how this one is working. What's this one? So you've got a user posting an update. So maybe they might be on Facebook. They might be posting an update. That update gets sent into an API gateway. So remember I said that API gateway is kind of like a web server, but then it can also accept inputs. So when you're doing post and update actions, you can send in messages. And so maybe that post update would get sent via API gateway into the Lambda function. And then what happens? Then it sends out a SNS notification. Okay, so what happens in this example is the user might have maybe 1,000 other friends that have subscribed to this user. And when this user posts an update, Lambda function will simply post that update to all of the users that are subscribed on the SNS notifications list. Yeah, so that's a few different patterns where AWS Lambda is being used. And again, in our analytics solutions or our decision services, we are running a similar type of pattern as this, where we've got users or web users, they're calling API gateways. Those API gateways are calling Lambda functions. And then in most cases, we normally have a DynamoDB as the backend, or we might not have any data backend and we might just process the data itself and then send back a response. All right. So yeah, again, Lambda is a serverless platform, meaning don't have to look after operating system, don't have to look after software. So no security updates, driver updates, or dealing with infrastructure, networking, all those kind of things. You just need to have your application code, make sure that your application code does work. We generally have been using Python. And when you code it all up, when it's all working and ready, you can upload it into Lambda. Lambda will basically host your application and then we'll start listening for any requests against the function. And it can do any number of things, so like file processing, streaming data processing, web applications, IoT applications, and mobile applications. And yeah, and it's just built based on consumption. Anyway, that's all that I think I wanted to cover. You can check out the AWS documentation overview. They've got a list of all the different features here, and they've got pricing. As I mentioned, it's pay per consumption. So here, Lambda pricing per second. I think this is how much memory? This is memory. Okay, yep. So this is based on how much memory your environment needs. So the minimum is 128 megabytes, I think. So this is just the calculation. And that's how much per million requests. So you pay 20 cents per million requests. Then you got a getting started page. They're talking about a hello world example here. Yeah, you've got some other examples and the resources. You've got the developer guide, API reference. So yeah, this is where you'd go to find out what Lambda can do, and then FAQ and partners. Yeah, so that's all I wanted to cover. All right, next one. Thanks.